Hi friends, welcome back. Today we are going to build this audio visualizer using this 74HC595 shift register and this sound sensor. And in my previous video I discussed about the detailed working of this IC using an interactive GUI based application. So if you want to know more about this IC, you can check out that video. So let's start building this project. So normally if you want to control 8 different outputs like these LEDs, you would require 8 different pins on any microcontroller, not just Arduino. But suppose if you don't have that many number of pins, so what will you do in this case? So that's where this tiny chips comes into play. The 74HC595 shift register IC. It lets you control 8 different outputs using only just 3 pins. Now here comes the interesting part. So in this project we are using this microphone module, which is basically a sound sensor. So what is the job of the sound sensor? This module collects the surrounding sound and this onboard chip converts that sound signal into a voltage level, and that voltage level is being read by this microcontroller Arduino. So you can see this output pin is connected to pin number A0 of the Arduino. Okay, and this Arduino convert that voltage into a decimal number from 0 to 1023. Okay, and based on how loud the sound is, we light up all these LEDs. Now before uploading the main program, you need to upload this code in the Arduino to check the value of amplitude in terms of analog reading. So this is the mic pin and these are the number of samples equal to 50 that we will take in one cycle, I mean in one loop. And in the loop function, this is the minimum value and this is the maximum value, because Arduino is a 8-bit microcontroller. So the maximum analog value it can read is 1023, and we are running this for loop for all the cycles 50. So the S is the analog reading. If S is greater than maximum value, we are setting maximum value is equal to S, and if S is less than minimum value, the minimum value will be set to S. So this maximum value is the upper bound and this minimum value is the lower bound. And obviously the amplitude will be maximum value minus minimum value, and we are printing that on the serial monitor. So the maximum analog value that we are getting on the serial monitor is around 987. So we will use this value in our main program. Now this is the main program, and here we are defining the starting 3 pins of the shift register, and with these 3 pins only we can control all the 8 different LEDs. And these are all the variables that we have just defined. Now this noise floor is equal to 8. Basically this is the threshold. Anything below it will be considered as silence, and you can adjust this noise floor value according to how much you want it to be. And this is the decay rate is equal to 1. It means how far the LEDs drop. And this is the peak level of sound. It is initialized to 0. And these are the patterns of all the 8 LEDs. Here we are turning off all the LEDs and here we are turning on all the LEDs. And this is the function update LEDs. Basically this is coming from the working of the shift register. So the working of the shift register I have already explained in my previous video. So I would recommend you to watch that video first. So the working of the shift register starts by pulling the latch pin to low. So the working of the shift register starts by pulling the latch pin to low, then the data comes serially on this data pin, and after shifting all the bits inside the shift register, we pull the latch pin to high. So this is the function get amplitude that we have just used in our previous program. And in the setup function, this is the startup animation at the very beginning, okay? And this is optional, either you can use it or just leave it. And in the loop function, we are calling this function get amplitude. And you can see that if the amplitude is less than noise floor, then we are setting the amplitude to 0. It means it will be considered as silence. And in this line we are mapping this range amplitude to 0 into this range maximum amplitude to 0, okay, for 8 number of LEDs. And we are finally considering the level from 0 to 8. And at the end we are calling this function update LEDs. So this was the entire program for this project. So let me know in the comment section if you want to add something in this project, and if you want more such videos and tutorials in future as well, then don't forget to subscribe to my channel, and we will meet with a new project in another video. Till then, goodbye and thanks for watching.